Oh, 6 marks. Oh, well, 6 marks, it just means more time really to work out the question. That's one thing you can focus on. 6 marks, 5, whatever. It's just giving you more time to work out what you need to work out. Let's see here. It says here, what does it say? Prove with reasons that F3 is equal to X. So let me just get a new sketch here. So with all the information we know, we need to prove that F3 is equal to X. Now, the one thing I can say with this question is, in the previous question, right, they had asked us to prove a cyclic quadrilateral, and we did. We proved that, what you may call, the shape here, AFED is a cyclic quadrilateral. Now, as long as you've proven that, it just means that in like follow-up questions, you want to look at that as a cyclic quad, and you want to make use of properties of a cyclic quad if they can help you. So that's one thing to take note of. So let's just put down what we already also know, right? We don't want to put out too much unnecessarily. Who's Richie? I don't know, but it doesn't matter. Anyways, so it says here, prove with reasons that F3 is equal to X, right? So where is F3? F3 is like this tiny angle here. They want us to prove that it is equal to X. So X, the unfortunate thing about where X is because is the fact that wherever we have X, right, we're trying to prove that this is equal to X as well. So we are obviously, the last thing you want is to jump directly to think, how are you going to prove that this is directly equal to that? That's the worst thing you can do. What you're better off doing is, in our sketch, let's label everywhere where there's something to do with X. And so far we have like, I don't know, like 3 more places. So there's X over here. Here we know that this is equal to 2X. Here we know that this is equal to X, as we have stated. This is double this one because angle subtended by the same angle at center is double the angle at the circumference if they're subtended by the same arc or chord. This is also equal to X because they're vertical opposites. And then we have also stated that this is equal to 2X. You see, so there are multiple places here where we have stated that our angles are equal to X. Now, the other thing we spotted in the beginning of the question was that this is a 90-degree angle because they told us that FK cuts BD in half. Now, the other thing you can also do with your questions is, normally, before you like finish with the question, try and make sure that the different things that they specifically highlighted have been used. Because so far in the previous questions, we have not yet used the idea that this is a 90-degree angle. So this may be a good space or a good time to be thinking about that. Now, obviously, when you're thinking of this being a 90-degree angle, and you trying to prove that this is equal to X, I mean, the one thing that you could maybe like help you is, for example, how, okay, you could focus on this tiny right angle triangle here. That may help you some way, somehow. Or you could focus on this big right angle triangle here. That may also help you some way, somehow. But we don't know. But it's a 6-mark question. It means that they have just given us enough time to like think. So in terms of like the thought process, I mean, you obviously, yeah, you can always revert back to the basics. Do you have any diameters? Do you have any radiuses? Do you have any cyclic quads? Do you have any parallel lines? Do you have any tangents? So we don't have a diameter of our circle, but we have a radius. So we know things like these 2 angles here. We know that they're equal to each other, right? So this angle here, maybe make it a bit tiny. I don't even know I'm stating this, but yeah, I'm just trying to milk everything really. So this is equal to this. Whether that's going to help us, we don't know yet. The other thing maybe we don't want to sleep on is our newfound information. We're dealing with a cyclic quadrilateral here. So if this is a cyclic quadrilateral, I mean, like, we do know things like how, I feel like what we just did here is useful. Here's why. This is 2X, right? And these are equal to each other. Now, after having to have written that down in the sketch, the one thing that came to mind was that we have an exterior angle out here that is equal to an opposite interior angle. We might as well even put that in purple, because just to show that they're equal. This, remember here, we have proven that this is a cyclic quadrilateral, like this shape here. Let me just put it in red like we did. This shape here, 1, 2, 3, 4 sides. We, in the previous question, they had asked us to prove it's a cyclic quad. Now, the fortunate thing is, say maybe you were not able to prove it's a cyclic quad. It doesn't matter. You should still use it as a cyclic quad in follow-up questions. Now, if this is equal to this, that's helpful, because in this small right angle triangle that we're trying to show that this angle is equal to x, what is somewhat about to happen now is that in this right angle triangle here, we are about to introduce x in there somehow, because in this triangle here where we say that this is equal to that, we can write these angles in terms of x, because interior angles of a triangle add up to 180. So what we can easily do is, let's state what we know without just keeping it in our heads. Let's state that these two are equal to each other. So FAD, FAD is equal to D1. The reason is base angles of an isosceles triangle. Base angles of an isosceles triangle. Now, the good news is, with this being said, right, we're trying to build some kind of a chain. And you can see how we got here is going back here. We literally went back here and we're like, okay, what do we have? We don't have a diameter, we have a radius. How can that help us? We have an isosceles triangle. How is that useful? These angles are equal. So because these angles are equal, we are now able to get a length for FAD. So now we can say, therefore, FAD is equal to 180 degrees minus this 2x and then divided by 2, because these are equal to each other. So if you take 180 and you remove this, whatever is left, you're going to cut it in half, because half goes there, half goes to the other one. So let's get a length for FAD. FAD here is going to be 180 over 2, 2x over 2, which is clearly just giving us 90 minus x. This is definitely useful, because now we have something to write here, 90 minus x. Now we can then say this FAD is equal to E1, which is definitely useful. FAD is equal to E1. The reason there is exterior angle of cyclic quad, you see. And you're seeing that we're slowly moving up in terms of our sketch, because as we said in the beginning, the last thing you want to do is to come from here straight there. No, we literally just plotted wherever else we have x, right? And then we're trying to get x into this shape, specifically this right angle triangle, because when you're going to deal with Euclidean geometry sketches, right, if you need angles, don't focus on the angle on its own, because an angle is useless on its own. An angle is something you can only work out normally if you're dealing with like a triangle, because if you're dealing with a triangle, you can see how you can make use of things like these laws here, of which here we're going to do exactly the same thing, one way or the other. As long as we're here now, as long as we can show that this is equal to 90 minus x, let's see, we said here FAD is equal to E1, right? Exterior angle of a cyclic quad. So here we can say, therefore, E1 is equal to 90 minus x. So that's like a mini detour, or like a mini checkpoint. Now, if you look at FKE, let's even draw it out here. FKE, because now this is our only focus. Everything else is useless now, because we have used it. Oh, okay, useless because we used it. That's a pun. So here, what we have is a 90-degree angle. This is 90 minus x. And then here we have F3. So if you look at it nicely, F3 is going to be equal to 180 degrees minus, what is this here? Minus E1. And then minus, what's this 90-degree angle? FKE. But I think before we can write this out, we may have to tell them we know that that's a 90-degree angle. Remember the whole 90-degree angle thing here. It's something we know, but we haven't told them yet. So let's just state it first. So this angle here is FKE. So FKE, you can say it's equal to 90. The reason is line from center bisects chord. There you go. So now it's clear that we know this is 90. So now we can make use of it. So here we're saying F3 is equal to 180 degrees minus E1 and then minus FKE. So if you write out the information that comes out from this, you're gonna have here F3 is equal to 180 minus E1. This is where we have to be careful. Brackets are important, right? There's 90 minus X here. And then here, this is a 90-degree angle. And then if we look at it play out, we're gonna have minus 90 here, plus X here, and then minus 90 out there. Of which we can see how here, this is 180 minus 90 minus 90. They just all go away. It's because this is like minus 90 minus 90, which is minus 180, of which 180 minus 180 is a 0. Then you're left with F3 here is equal to X. And then they're gonna give you your 6 marks. You see?
Yeah.
Perfect. So you can see the whole goal, whatever the goal was, it was not like straightforward. We literally, the fortunate thing is you saw how, okay, we didn't just jump to the answer. We stated out what we had. And then the one thing we also did not forget is what did we just work out? This cyclic quad. And you can see how the cyclic quad was more or less the game changer. And another thing that was a game changer was what you may call, this radius. This was also where it all started, how this we can incorporate a 90. So everything at the end of the day, it's definitely always gonna stack up. So nothing is like on its own.